Hello everyone. In the previous video, we have seen the working of the bubble sorting algorithm. Okay, bubble sort algorithm. Here we are going to implement the bubble sort algorithm, right? So let me call it as implementation of bubble sort algorithm. Implementation bubble sort algorithm, right? So first and for to perform bubble sort, I'll be having a separate function to perform bubble sort. Okay. So first I will write the code for swapping because anyway it is based on swappings only, right? Swappings and comparison. So I have to make a code for swapping, this for swapping the elements. Okay, and this is going to be based on the the pointers concept because for swapping I'm going to define a separate function. I have to call the function by reference only. If I simply call the function by the values, then only in this function the values will be swapped. In the original function, that is in the bubble sort function, the values will not be swapped. So here I'll be having two pointers. Let me call it x and y. I'm having two pointers here. Okay, so I'm getting two pointers here. This function is basically a void function. I'm not going to return anything. I simply have to swap the elements, that's it. So let me say I'll be having one more variable called temp. Okay, so I'm going to use swapping with three variables. Okay, so temp, then I have to say the value at x. So whatever be the value at x, that will be stored in temp variable. Then whatever be the value at whatever be the value at y, that should be stored in the value at x. Okay, whatever be the value at y, that should be stored in this value at x. Okay, that should be stored in the x. Then whatever be the value at temp, that should become the value of y. Okay, whatever is the value of temp, that should become the value of y. Temp actually holds the value of x, so value of x should be assigned to value of y, and here value of y is assigned to value of x. So we are now done with the swapping algorithm, right? So this algorithm will definitely work. All right. Now we will have one more function which I will name it as bubble sort. Okay, which I will call bubble sort, and we will be having the array first of all. Okay, we will get the array and we will get the size of the array. So these are the two basic parameters that we have to get because anyway we will be sorting the array only. All right, we will definitely be sorting the array. We won't be you know searching for any element like in search algorithms, right? We'll just be sorting the array, so there is no need to get anything else other than the array. Okay, size also if you want you can get, or you can compute in the function itself. Okay, it doesn't matter, right? So I will be having two pointer variables. Okay, we know that we have discussed in the previous video, for ith and jth element. So we have to make comparisons between those two, right? We have to make comparisons between two elements at time. So for that we need two pointers. That's going to be ing, right? And I'll let me have a variable called is swapped. It's going to be a boolean variable, so let me call it is swapped, which will you know inform us whether all the elements are swapped or not. Okay, why do we need this? Because if all the elements in a particular pass are not swapped, if none of the elements are swapped, okay, none of the elements are swapped, it means that the array is sorted, right? None of the elements are swapped. In that case, what we have to do is we have to make it false. Okay, so none of the elements are false. So when none of the elements are swapped, we have to make it false. Okay, in this case exactly the third pass, no swap has been happening here, so we have to make the swapped variable to be false here. All right, otherwise we will keep it true. Okay, all right. Okay, whenever we perform a swap, we will change it to true. Okay, that's it. Then we have to start writing a loop. So the outer loop will go from I equal to 0 up to size minus 1, right? Up to size minus 1 I plus plus, right? The inner loop should go from j equal to 0, j less than size minus 1 minus I. Okay, minus I plus j plus plus. Why minus I? Okay, size minus 1 is perfectly fine, but why minus I? This is because of the reason that in each pass one element will be sorted. Please try to understand that if you have completely randomized element, then the general procedure is in each pass one element will be sorted. After the end of first pass, 9 will be sorted, right? So it is enough for the next pass if we check only at the first four elements. Okay, so it's gonna be j minus I minus 1. Okay, I mean n minus I minus 1. Okay, n minus, if n is equal to 5 means, so 5 minus I is now 1, right? At the first pass means I is 1. At the second pass I is 1. first pass I is 0, right? So for second pass I is 1. So total number of elements in array is n. At the second pass I becomes 1. I will again have 1. So 5 minus 1 will become 3. So I will start from 0. I'll go only up to 3, right? I'll go only up to 3. All right. I won't check the last element. Okay. Before the second pass, and after the second pass also, I will I will start from 0. During the third pass, I will start from 0. I'll go up to 2 only, because after the second pass, I know that the last two elements are sorted. The last two elements are sorted. So to keep track of that, we have to subtract I, right? We have to subtract I. All right. And here, the outside of the loop, I have to say is swapped equal to false. Okay. So no swapping has done outside the loop, right? No swapping has done outside the loop. But inside the loop, if there is any swap, so I will call the swap function. All right. Before that, I have to write a condition, right? So let me say if array of we know the condition. I have already explained the condition. No doubts about it. If array of j is greater than array of j plus 1, I can do like this. Okay, I can. So because this I will keep track of the number of passes, j only is going from j, starting from 0, it goes up to I only, right? So here I could call, here I could say that, here I could say that, I'll add a new page. 2 3 6 5 9. If that, if this, these are my elements, here I could simply say this is j and this is j plus 1, right? Next element is j plus 1, so I can simply compare these two like this. Okay, again j is incremented, means this will be j and this will be j plus 1, right? This will be j plus 1. Okay, so I can simply compare two elements like this, because I will keep track of the number of passes I'm making, right? Number of passes and I am making, right? So this will make sense, right? This is making sense. So here, if array of j is greater than the array of j plus 1, that is, the current element is actually greater than the next element. In that case, I have to swap, okay? Because the current element has to be smaller than the next element. That is exactly the sorted order, right? So I have to swap it in that case, okay? So here I have to pass the uh, address of array of j. So we have to pass the address only, because here we are getting some pointers which will store address only, right? So array of j, then address of array of j plus 1, right? Address of array of j plus 1. All right. So since we have made swap, since we have made a swap, we have to make each swapped variable to be true here. Okay, each swapped variable to be true, right? All right. And finally, after this inner loop is done, after this inner loop, we have to check. Okay, we have to check whether this swapped equal to true or not. Okay, so if it is, I mean, false or not. If it is equal to false, then it means that it remains in false only. You just try to understand it logically. It is initially false. Inside this loop, if if we are making swaps, we are making it true. If the current element is greater than the next element, we are making swaps. If we are making swaps, we are making it true. What if the array is sorted? If the array is sorted, this condition will not become true anymore. The array is completely sorted means this condition will not become true anymore. So is swapped will not become true. It will remain in false only. Okay, it will remain in false only. So I am checking whether it is remaining in false. If it is remaining in false, then it means that I have not done a single swap. Okay, I have not done a single swap. That means the array is sorted. So I can simply break the outer loop. Okay, since I am writing it outside the inner loop, I can simply break the outer loop, which means that the array is now sorted. Okay, so this is gonna be my bubble sort function. I hope this is clear. Now I will write my main function. Okay, here first of all, I'll be having my array here. So let me say my array is 2, 4, 3, 7, 6, 9. All right, so these are my array elements. Okay, which obviously they are not sorted. Okay, they are not sorted. Now the size of the array is, let me declare it like this. The size of the array is gonna be, all right, the size of the array is what, 6, right? Let me have it 6. Okay, anyway, you can use the way which I told you in the searching algorithms to find the size of the array, but let me simply declare it 6 here, time being, right? So now I will call the bubble sort function. Here I can pass the array as well as the size. Those two parameters are necessary here, right? That's it. After that, I will simply print the array element by element. I will print the array. To print the array, what I have to do? I have to go for a loop, right? So let me say int I. Let me have one for loop to print the array. So it will start from 0. It will basically go up to size minus 1, and it will say I plus plus. So during each iteration, I can print a single element of the array, right? So I could say array of I. I hope this is making sense. So the idea is very simple. Based on a single condition, if the current element is greater than the next element, swap it. Okay. And do it again. Do it again until the array is sorted. Very, very simple algorithm. Swap it and do it again until the array is sorted. Once the array is sorted, is swapped is false, so you break the loop. Okay, you stop swapping. Okay, you stop comparing the elements. Okay, you need not compare the elements anymore. The array is sorted, right? So very, very simple algorithm. Okay, so now let me check for syntactical errors. Yes, there is one syntactical error. It must be here, right? Size minus 1 it has to be. Anything else? One more syntactical errors. So here I need not put like this while calling the function. I can simply say R. Okay. Right, while printing, what we can make here is we have made size minus 1. We have made it actually less than size minus 1. So it will not go up to the last element. We have made it less than size minus 1, right? So it will not go up to the last element. So what we can say is we can simply make it size. That will make sense, right? Yes, now 9 is there, right? Now 9 is getting printed. Or else you can even make like this, I less than or equal to size minus 1. This will work. It will go up to the last element, right? Size minus 1 is our last element. So if you put equal to, it will go up to the last element. But if you don't put this equal to sign, it will stop at size minus 2. That is the element which is present before the last element, right? Okay, I hope you got the mistake that I have done here. Thanks a lot.